Okay, so today's the day that we kind of put it all together. So we've been talking about how to write the equation of a line given different pieces of information. So given slope and y-intercept, given slope and a point, given parallel or perpendicular and a point, or just given 2 points. Today we're going to look at this in the context of some word problems, some application problems. And so the piece here that kind of adds a layer of difficulty a little bit is being able to determine what pieces of information are we being given. So we still want to write our equation y equals mx plus b. Now finding our slope is usually the easiest piece to find. Now slope we know is a rate. So anything that's a rate, many times associated with the word per in a word problem, per week, per month. That's going to be the slope of our line. Now for our application problems, we're really many times just looking at that first quadrant of our graph. And our y-intercept is going to be the initial point in that graph, and then it's going to grow or decline from there. And so we can think of our y-intercept as an initial amount, a starting amount. So if we're given some initial starting value or some initial amount that we can use as the y-intercept, we'll want to pick up on that piece as well. The last thing that we could be given is an x and an xy value that's on that line. And so an xy value I call a piece of information. So if as we read that application problem, we're like, that's not an initial amount, that's not a slope, that's not a rate, it's just giving me some information, probably we can put that information into an ordered pair and then use that to get the equation of my line. So let's look at our first application. So it says, Abigail is saving money to purchase a new computer. She currently has $320 in her bank account. That's an initial amount. Okay, that's what she has now. That's what she's starting with. She plans to set aside $20 a week, should say like $20 per week. Okay, 20 a week. That's her rate that she's saving at, or M, initial amount B. So this application problem gives me a slope and gives me an initial amount. All I need to do is put that into my equation. So for this one, I don't have to do any solving. Just going to put those together into my equation. Okay, here's my equation that represents Abigail's saving for her new computer. She has $320 and she wants to save $20 a week. Now it's good to identify what our variables represent in this equation. So X being multiplied by the $20 going in per week, X is the number of weeks that have passed by. And we're going to plug in, we could be able to plug in certain values for weeks. It would give me out the amount of money in her account. So then that helps us when it asks us a follow-up question to know if the piece here is an X or a Y value. So it says if the computer that Abigail wants to buy costs $600, after how many weeks of saving will she have enough money to purchase the computer? So for this, we need to know that money, and that's why we labeled up here, is a Y value. So I'm going to take my equation, 20x plus 320, and I'm going to set it equal to 600. 600 is a Y value. And then I can solve for X, so I subtract 320. And 600 subtract 320 gives me 280 equals 20x. Then I divide by 20. Cancel out those zeros. 28 divided by 2 gives me 14 weeks. After 14 weeks of saving, Abigail will have enough money in her account to purchase the computer. I want you to read through example number 2 and see if you can set up the linear equation that models that situation. So on number 2, you have $100 for a graduation present and you deposit in the savings account. And then each week you add $5 to the account. This is another example of something that's giving you a starting point of $100, so B, is $100, and it's giving you a slope or rate that you're adding $5 to the account each week, okay? So I can write an equation. Your equation, you should have had y equals 5x plus 100. There's my equation. And where x is the number of weeks, and it could have been like months or number of years, so we want to make sure to reread the problem. It's each week, so x is the number of weeks, and y is going to be the money in that account. So we're going to use that equation to determine when you'll have $320 in your account, which means we would plug that in for y and subtract 100. So I'd have 220 equals 5x. And dividing 220 by 5 gives me 44 weeks. Also notice when I write my answer here, I'm using words. So I wouldn't just say 44. 44 what? Is it going to take 44 days? Is it going to take 44 months? No, it's going to take 44 weeks. Okay, so make sure you're answering your word problems with words. Let's look at another example. So here, there's a few things we have to be careful on here. So first of all, the information we're given is different in this example. And also we need to be thinking, so on the first two, we were always adding money, okay? On 3, it says Marty is spending money at an average rate of $3 per day. So I can identify this as a rate, or that this is going to be my slope, but he is spending money at that rate, which means I am decreasing by 3 each day, okay? That my slope is negative 3. And then it tells us that after 14 days, he has $68 left. That's not an initial amount. It's the amount after 14 days. So this is what I mean by a piece of information. Okay, this is just some info that I can then organize into an X and a Y value. Okay, and the amount left depends on the number of days that has passed. This also tells me my X and my Y, because we know we have a function here. So it's saying the amount left, Y, is dependent on the input being the number of days. So when I look at my equation and I know that my slope is -3, I don't know my B value, I'm gonna have to find it, but X is the number of days that has passed and Y is the money remaining. So when I think about this ordered pair, I know that 14 is the X value because that's days, and 68 is the Y value, okay? And if I know that after 14 days of doing this, spending money $3 a day, that he has $68, if I plug that in, I'll be able to figure out how much money he started with or what his B value is. So I'm going to plug in 68 for Y and 14 for X. And I'll be able to solve for B, so -42. And add 42 to both sides. And I get a B value of 110. Putting that together, BM, put it together into an equation, Y equals -3X plus 110. Okay, so this problem was different because it didn't just give me slope and y-intercept and I could make a line. It gave me slope and some information that I can use to find my y-intercept and get my line, okay? Then it says, what does the y-intercept represent? Well, just like we listed on the first page, it's an initial amount. So in terms of this equation, it's the amount of money Marty started with. Okay, and then he started spending $3 a day. 14 days later, that $110 became $68 and so on. Now, eventually, if you just keep spending money, Marty, you're going to run out of money, right? So it says, how many days would it be until Marty runs out of money? Well, in our equation, y equals -3x plus 110, we know that this is days and this is money. If we're talking about running out of money, then we want to know, when will we have no money? When will y be 0? And so I can solve for the number of days that would take. I would subtract that 110 and divide by -3. Now, 3 does not go in evenly to -110. If I look at that, so 110 divided by 3, 3 goes into 11 3 times. That's going to give me 9. And it's going to give me 20. 3 goes into 20 6 times, gives me 18, leaves me with 2. So it's 36 days, 36 and 2/3 days. This is my remainder, is 2. Okay, or X is 36.67 days. Okay, it doesn't go in evenly. So would Marty be out of money on day 36? Not technically, he'd still have a little bit of money left. He wouldn't have a full $3 left to spend on that last day. But on day 37, he would be totally out of money. Okay, if he just continued to spend $3 a day. By 37 days later, he'd be out of money. Okay, so now I'd like for you to look at 4, see if you can figure out what pieces of information are there and get the kind of basic setup, and then continue the video and see how you did. So on 4, similar to 3, it's talking about something being a loss of something. So we are losing weight, which means this is giving a 2-pound a week weight loss. That's our slope, but it means we're going down, we're decreasing each week. So my slope is negative. And then it gives that after 5 weeks, Sheldon weighs 192 pounds. So again, this is some info or some XY value where I know that after 5 weeks, we weigh 192. I'm going to put that together in an equation, y equals mx plus b, and I still need to find what my b value is. So I'm going to plug in my slope is -2. I know that after 5 weeks, he weighed 192. What I don't know is my b value. Okay, so I have an x, y, and m. I'm going to find b. 192 equals -10 plus b. Add 10 to both sides, and I get 202 equals b. Putting my slope of -2 and my y-intercept of 202 together, here's the equation that models Sheldon's weight loss. Okay, so here's the equation. Then it says use the equation to determine Sheldon's starting weight. Starting weight, initial amount. This is all about understanding that the B value is the initial amount. So Sheldon's starting weight must have been 202 pounds. And I didn't have to do anything to figure that out, except for understand that the y-intercept is my starting amount. Now Sheldon, so after 5 weeks, he weighs 192, but Sheldon has a goal of getting to 160 pounds. How many weeks does he need to commit to his plan? So here's my equation. And we know X is the number of weeks, 2 pounds per week, and Y is going to give us his weight. So we want to know when will his weight be 160 pounds. And then I can solve from there. So subtracting 202 gives me -42 equals -2x. And dividing by -2 gives me 21 equals x. And we should respond to word problems with words. So we're not just going to leave x equals 21. We're going to say, well, it would take 21 weeks for Sheldon to get to his goal weight. Okay, now let's look at the last couple of problems we have here. Okay, these are our most challenging ones. I love this one. I love this one, I think, only because it's a Curious George episode. So if anyone's watched Curious George before, Curious George had a day where he was hearing a cricket chirp and he was writing in his journal, and he was noticing that at different times of day, the cricket was chirping differently. Okay, this is the same concept, but in a math problem. Okay, so the Curious George writers, maybe they did this math problem as kids and then wrote it into the script. So what happens is that the temperature outside is related to the number of chirps that a cricket's making. Okay, and so if you listen to a cricket chirping, we'll see that the colder it is, the less the cricket's chirping. Okay, and then eventually it gets so cold, we know here in the winter, we don't hear crickets chirping after it gets to a certain degree. So it says, biologists have found that the number of chirps crickets make per minute is related to the temperature, and the relationship is very close to being linear, meaning we can represent it with a line. It says when a cricket chirps 124 times a minute, it's about 68 degrees outside. Okay. And if it's chirping 172 times a minute, then it's about 80 degrees Fahrenheit outside. 80 degrees Fahrenheit outside. Now, neither of those sentences gave us a slope. Okay, we don't know what the rate is that they're chirping. We do know per temperature increase. So we do know how many times per minute it's chirping, but it's related to only a specific degree. We don't know the constant rate as the temperature gets higher, how many chirps is it increasing by? That would be the slope we'd be wanting to find. Okay, so what this is giving us is 2 points. And it tells us that X is the temperature and Y is the chirp. So you got to be careful here because it gives us chirps first and then temperature. But the way that I'm going to translate this into an ordered pair would be 68 degrees is 124 chirps. And if you think about how you'd want to use the equation, you wouldn't want to have the input be chirps. Okay, it's a lot easier to have the input be the current temperature, right? Because finding out the current temperature is pretty easy. Figuring out how many times a cricket's chirping per minute, a lot harder. Okay, so when you're thinking about how I should set up my ordered pair, think about what would make sense for an equation. It would make sense to be able to put an input of temperature and get an output of how many chirps you would expect to hear. Okay. Now the other piece of information I have is that it's 80 degrees, the cricket's chirping 172 times per minute. So now we want to write an equation, but we have 2 points. When we have just 2 points and we want to write an equation, we start by finding slope. So I'm going to do 172 subtract 124 over 80 subtract 68. 172 subtract 124 gives me 48. And this gives me 12 in the denominator, and that goes in evenly. So my slope is 4. Now that I know my slope, I can start writing my equation. I know my slope, but what I don't know is B. So I'm going to use one of my points. I'll choose 68 and 124, and I'm going to plug in 124 for Y and 68 for X, and I'll solve for my missing B value here. So 4 times 68 gives me 272, and subtracting 272 gives me negative 148. And I can take B and M and put it together in an equation that looks like this. Okay, so there's my equation that models the cricket situation, where let's talk about what this means. My slope would be how many additional chirps there would be per increase in temperature. Okay, so here, this would mean with each increase in degrees, with each increase in degrees Fahrenheit, a cricket chirps 4 more times. So if it went from 68 degrees to 69 degrees, then I would expect 128 chirps. If it then went to 70 degrees, I would expect 132 chirps. Okay, it would keep increasing with that temperature. Each increase in single degree Fahrenheit would give me 4 more chirps out of the cricket. Now my y-intercept would mean when it's 0 degrees Fahrenheit, I have negative 148 chirps, or in other words, there's no chirps. Okay, if it's 0 degrees Fahrenheit, there's no chirping crickets. And in fact, there would be a value, right, that I would get to 0 chirps. And that would be when our crickets go and hide somewhere and we don't hear them chirping outdoors anymore. So it does ask us, I kind of wrote over it, a follow-up question of how warm would it be outside if you heard a cricket and it was chirping 150 times per minute. So 150 times per minute, that chirp is a y value, right? If we go back to our ordered pairs, chirps are a y value. So I'm going to take my equation for x, subtract 148, and I'm going to plug in 150 for the number of minutes, or sorry, for the number of chirps I'm hearing per minute. Adding 148 over gives me 298 equals 4x. And dividing by 4, so 298 divided by 4, 4 goes into 29 7 times. Gives me 18, 4 goes into 18 4 times, gives me 16, leaves me with 2. 2 out of 4 is a half. So x is 74.5 degrees Fahrenheit. And remember, we need to answer in the context of the problem. So not just 74.5, but 74.5 degrees Fahrenheit would be what we would expect how warm it is outside if a cricket's chirping 150 times per minute. Okay, so now what I would like for you to do is look at number 6. Now I want you to think about, number 6 again is going to give us 2 ordered pairs. I want you to think about how would you organize those ordered pairs? What should be x and what should be y, right? And see if you can write down what the ordered pairs are and then continue the video. And then pause it again and see if you can write your equation, but make sure your ordered pairs are correct before you go through the whole process of finding the equation. Okay, so I'm not going to pause the video for you, just go ahead and pause it and then check. So it says that in humans, the femur length is a function of height. So the length of that bone in our body is linearly related to our overall height. During an excavation, 2 different skeletons were found. Person 1 had a 20 centimeter femur and was 162 centimeters tall. Person 2 had a femur that was 45 centimeters and was found to be 173 centimeters tall in height. Write a linear equation that models this. So what we are going to have, we want to think about what we want our input to be. So I'm going to have my input be the femur length. That way, if we find a single bone, right, we find a femur, we can make the estimate of the height. We can't really, we can hope to find, I guess, every single bone of a skeleton that we're digging up, but we can't assume that we will, or that it will be 100% accurate what the height is. But if we can find that femur bone, then we would be able to put that value in and get an estimate on the height of that person. So I'm going to have the length of the femur be x. So when the femur length was 40 centimeters, the height was 162 centimeters tall. When the femur was 45 centimeters, the height was 173 centimeters tall. So now I want you to pause the video again. I'm going to continue on, okay, but pause it. You will get a fraction for your slope. It works out okay. And see if you can get the equation that models the situation. So first thing I would do is I would start with slope. So slope between these points, 173 subtract 162 over 45 subtract 40 is going to give me 11 in the numerator and 5 in the denominator. And I can't clean that up at all. I could, in terms of thinking about this actual equation, I can think about this as this is 2.2, which will just kind of help us when we think about what our equation means. But I'm going to leave it as 11/5 for right now. And then I'm going to grab a point. So I'll grab this point in a slope and y equals mx plus b, right? So I know my slope is 11/5. And I'm going to plug in 162 for y and 40 for x. And this works out nicely because 40 divided by 5 is 8. 8 times 11 gives me 162 equals 88 plus b. And I just subtract 88 from both sides and get 74 for my b value. And so y equals 11/5 x plus 74 would be the equation that models this. So the 11/5, the slope would represent that for each additional centimeter in femur in femur bone, I would anticipate an increase of 11/5 or 2.2 centimeters in height. Okay, so for each additional centimeter in femur length, the height would increase by 2.2 centimeters. Okay, that's what my slope means here. That's why it's nice to kind of think about the decimal in this case. It's a little silly to say 11/5 of a centimeter. And then the y-intercept 0.74, that's kind of weird. That would be like 0 centimeters of the femur is a 74 centimeter tall person. Now, obviously there's no person with a 0 centimeter femur. So that y-intercept doesn't make a ton of sense in terms of actual reality of what's happening there. But then again, you'd never be plugging in a femur that's 0. So it just means that given even a small femur, okay, femur that would be only a couple centimeters, you're still going to have a height of at least a small child, right? So this isn't a negative y-intercept, and it's kind of a high number to think about, but remember, we're thinking about centimeters here. So yeah, y-intercept's a little nonsensical in this example, but that's what it would be if we were to list out what that means. So then, so now that we have this equation, right, we could go dig up all the bones we want and make some estimates on it. And it says here we found a femur bone that's 43 centimeters long. We can use the equation above to estimate how tall that person would have been. And so we take our formula, and 43 centimeters for a femur, we'd plug in for X. And I'm just going to tell you I cheated and used a calculator here instead of dealing with the messy fractions. And it gave me 168.6 centimeters for an estimate on the height of that person. Okay, so you'll get some more practice with the linear equation applications. I was going to pull if I have it, the homework that you have, but I don't think I don't have it out. And this is tricky stuff, okay? And part of it is that the more you practice determining what pieces of information you have, the easier it gets, really. And so we'll continue to practice this. We'll definitely talk about it over Zoom sessions, but use these problems as examples. So if you notice, I gave you two problems that it gave you just slope and y-intercept, easy peasy, we made our line. Then I gave you 2 examples where you were given slope and a point. And then I give you 2 examples where you were given 2 pieces of information or 2 points. Okay, so use these as you work through the examples in the next few days that involve the application problems.